Now, in the previous class, we learnt about sampling distribution, types of sampling. Okay, what are the major two types? Probability, non-probability sampling. And then we understood what is standard error and all that. Okay, just to summarize all of it. Now, let us take for example, we have been solving correlation and regression problems. Right? Now, in correlation and regression problems, whenever we solve, we were first finding out the X bar, correct? So we were trying to find the mean. So when we see the data, we will first find the X bar. If the X bar is of a whole number, then we will proceed with actual mean. And if at all this X bar has some decimal points, then we will go for assumed mean. So this is what we were trying to do. But in that correlation and regression, we were given the data, right? Let's take for example the sales and advertisement. The relation between the sales and the advertisement was given to us. So there the data was given and we were finding the values. But in this chapter, that is sampling distribution or sampling and sampling distribution, we are having this data, we are having this part, that is X bar, or different types of X bars, that is means, will be given to us. We have to find out this data. We are doing the reverse situation. So this is the basic understanding that you will have to have. Now let us take another example. Now there is a bag. Okay, there is a bag, and this bag has color balls. Okay, this bag has color balls. Now let's say this bag has somewhere around 500 balls. The small rubber balls or something you get, no, which is very colorful and all that. So let us say that that bag has color balls, and the total number of balls that is there, the color balls that is there in that, are 500. So 500 will become the population. So 500 is the total number of balls that is present in the bag. So this will become the population. Okay. Now from this bag, I will close my eyes and I will pick 5 balls. Okay. From this bag of 500, I'll pick 5 balls. Now let us say first ball is green color, second ball is blue color, then it is white, yellow, orange. Okay. Now I had closed my eyes and I don't know what color balls are there inside and nothing I knew. I just picked 5 balls from that. Okay. So this 5 balls which I've picked from that bag, which were, let's say these were all different colors. Now this 5 balls which I have selected here, these are called as sample. Okay, are you all able to follow? Now I have a population which is the bigger number. Now from that bigger number, I have selected 5 balls from the bag, which is my first sample. Okay, now for this first sample, I will find out the mean. Okay, for the first sample, I will find out the mean. So this will become X bar 1. So if you see here, sample mean X bar 1. So first time when I take out the sample, I will take that 5 balls, which will become X bar 1. Okay. Now I will put back all the balls. All this 5 balls is put back into the bag. So in my hand, there are no colorful balls are not there. Now again, we are going to select, we are going to pick. Now I'll call one of you and I'll say, come take out 4 balls. 4 balls from the bag. Now for the second time you're picking the balls from the bag, This time you are selecting 4 balls. Now it is randomly selected. You do not know which color balls are there inside the bag. It is randomly selected. So it is a random variable sample. So we are randomly selecting here. We don't know what is there. So the result, let's say this, out of the 4 balls, 2 balls you got it as white and 1 ball is yellow and 1 ball is blue. Now, you did not know that you had selected 2 white balls. Okay, so here this is the second sample. This is the second sample, and I will find the mean of this sample also. So this sample mean will become x bar 2. Are you all able to follow? Are you all able to understand now? Yes? Okay, good. So like this, I will keep taking samples. I will keep taking different samples from the bag. It's just like a game. You would have seen that lottery game, right? Okay, Akhila still has problem in understanding. Akhila, are you following or do you want me to explain it again? Okay, I don't see her. Okay, let us see. Let us see what can be done. Maybe I'll take a different example later and I'll explain it again. Now, understand here. So, first time I took 5 balls as sample and I calculated x bar 1. Second time I took other 4 different balls and I'll calculate the sample mean for that. Okay, so that will be your sample mean, and sample mean for first sample and sample mean for the second one, third one, so on will be different. They will not be same because we are randomly selecting, so they will be different. Clear? So this sample mean will vary, will be different from one sample to another sample. Maybe first time I have got 2 as the arithmetic mean. Now next time I will get 5 as the arithmetic mean. I might get any number. So the arithmetic mean, the sample mean will be different. Did you understand till here? Any doubts until here for anyone? Understood. Good. Everybody understood? Okay. Now, this sample mean, whatever we saw here, that will be called as, that is also a parameter, that is called as a statistic. Okay. It is a benchmark for me. Okay. It is a benchmark, or it is a deciding criteria for me from the sample that, see, this is what we are collecting. So one of the criteria for selection is the sample mean, and that criteria together is called as, that the other name of criteria is statistic. So this is one thing. Now we have found out arithmetic mean, right? We have found out x bar 1, x bar 2, we are finding out. Now another parameter or another deciding criteria which I form here or which I use here is called as sample variance, or it is denoted as S square. Now, what is this sample variance? Now, variance means, okay, the meaning of variance is how far, okay, how far the number is from the mean. Now, let us say, for example, the same bag here, I'm taking it here once again. Now, let us say there is one ball inside the bag, which is white in color. Another white ball is somewhere here. Another ball is here. And one ball is next to each other. So, how far, let's say if this is the mean value, how far is the other number from the mean value we will be calculating. That is known as variance. And since we are calculating it for the sample, okay, it is called as sample variance. Did you all understand what is variance? How far is the number from the mean value? Okay. Another easy way to understand the sample variance is through normal distribution. Now let us take another example. Marks of test. We will find deviations. You remember? X minus X bar. We'll find the deviation. This is nothing but the variance. We are finding how far the marks of the test is different from the average marks that the student has got in the examination. Now let us say for 25, the average marks everybody had got was 18. Average. This is the average. Now, few of them would have got 9, 6. Few of them would have got 22, 25. So I will find the difference between the number, that is the marks, that is X, and the mean, that is X bar. So this is a way of finding the variance. There are many other ways, but this is one of the way of finding the variance. So I'm finding the difference between the numbers, how far it is. So since I am doing the difference in the sampling distribution or for the sample, it is known as sample variance. Now, did you understand? Any doubts in sample mean and sample variance? Everybody understood? See, this chapter is very, very easy because you don't have higher end test and all. Okay, the test means not your unit test. I'm talking about statistics test. Okay, so here you will only have the basics of the sampling. So it's very easy. Only thing that you'll have to understand is the concept of sampling. Okay, and this sampling and sampling distribution is widely used in research. So this semester of statistics, whatever you're learning, is widely utilized in research. Research means not scientist. Okay, I'm not talking about that medicinal research that may be used, that in that also it is used, but for your field, for your commerce field to understand, we use these simple means and variance and all that in every small research to the big research. Now, even in finding out COVID vaccine, they would have used all of these values. Okay, manufacturing of medicine. Let's say they want to manufacture a cough syrup for babies. Now, for babies, the cough syrup, the content of that drowsiness, all that has to be monitored, right? All that has to be monitored. So they will take out different samples of that cough syrup. So let's say in one of the cough syrup, the amount of drowsiness is, let's say 10%. In the other one, it is 5%. Like that, they will find different samples and they will check, they will do further observation on that, and whichever they see is the perfect sample, only that will be manufactured. In that also sampling distribution is used. Here we are understanding it with numbers. Scientists practically do it with the liquid or the materials. Now, even while finding vaccine for COVID, now you would have heard about BCG vaccine, which was given to every person, okay, or polio vaccine, which everybody has taken, that polio drops and all which we have taken. That will also help us to be very immune, to be away from COVID. How did they come to the conclusion? And they came up with that HCl drug, which is being used by doctors. Okay, people who are directly working along with the COVID patients, those people take that HCl medicines because that will keep them away from the coronavirus. How did they come to the conclusion? It is because they have taken the samples, they have calculated the variance, they have calculated the sample means, they have done more research by applying different tests on it, and then only they come to the conclusion saying, yes, this vaccine will work. It will not end there. They will decide, and then they will do the trials on the human being, and they will see the reaction. Every body will give a different reaction. Like how we have every sample will give a different mean, every body will give a different reaction for the medicine. Now, say suppose few, if they take Saridon, there is no problem, their headache will go. But for few of them, if they take Saridon, they'll start vomiting, because that Saridon gives a different reaction in their body. Right? For few of them, they don't mind gulping down any tablets. For few, they don't, their body does not digest any sort of tablets. They just leave it as it is to go away. Right? So every body reacts in a different way. Every sample reacts in a different way. So here we are not dealing with any chemistry or chemical. So we are only learning. See, that is practical part. Here we are learning how to solve it using the numbers. Now in the news, they will say your data. Let's say on the Bandh day, there was some Bharat Bandh which happened recently, two days back or 1 day back. So they told, okay, on this day, so much of profit was, or so much of business is lost. Or they will give you a statistics. This year, there were 15,000 vehicles. Sorry, not 15,000. That's very less. Let's say 15 lakh vehicles were purchased. New vehicles, 15 lakh new vehicles were purchased. From where did they get all that data? Obviously, they'll take it from the showrooms. But how many showrooms can they go? So they will take a sample and then they will find the population. Are you all able to understand? Are you all able to relate it now? I'm trying to making it as easy as possible, because I understood that you were not able to relate to the concepts very easily. Now, are you clear? Any doubts? Okay, great. Now, let us see the standard error. So we understood what is sampling distribution. We understood what is sample mean, sample variance. Now, sample mean and sample variance are called as statistics. Okay, statistic. So this is the judging criteria. Now you judge event, you have some criteria, right? How do they look? How do they walk? How do they talk? How do they dance? So there is criteria. So similarly, that another name for criteria is statistics. And what are that? Sample mean and variance will be part of statistic. Now similarly, for population, now we understood for sample, now for population you will have population mean and population variance. For sample, you have sample mean and sample variance. For population, you have population mean and population variance. So population mean is denoted like this, which is known as mu, M-U-E, mu. Okay, so you just have to put a line and then write a cursive writing U, which is known as mu. And population variance is nothing but standard deviation square. So this is standard deviation. If you square it, it's called as standard deviation square. So this is population variance. So this population mean and population variance are the judging criteria for the population. How sample mean and sample variance is judging criteria for sample. Similarly, population mean and population variance are judging criteria for population. And like how you have the name for sample, that is statistic, for population it is called as parameter. Okay, for population it is called parameter. So how do you judge the population? You judge using parameters. How do you judge the sample? You judge using statistic. So that is your population and sample. Now the next concept is standard error, which is present here. Now standard error is nothing but we are seeing how accurate is the data. Now let's take the same COVID vaccine example. Now COVID vaccine example, they have come up with some medicine. They will mix something and they've come up with some medicine. Now we do not know if the medicine will work really or not. They would have thought it will work, but there are a lot of complications in the human body which may get set to one person and which may not get set to another person. Okay, and there was one person who actually died after he got the trials. That's what I read in some news. I don't know to what extent it is true. So we have to know the accuracy of the sample that we have taken. We have to see how accurate, how correct the sample is. And it depends on the confidence level that we have put into the sample. Okay, so usually confidence levels are taken on certain standards. Fine. So you will usually have 95% confidence level, 90% confidence level. It means you are 90% sure that it will work. In 10% you can expect error. Yeah, it can happen. So I can say I am 90% sure that the whole class will pass the examination. 90% I am sure. 10% I doubt because somewhere some person would have left out few problems. That is the standard error. It is showing me the relationship between the dispersion of observation around the population mean. So this is more technical in nature. In easy words, it is just saying that to what extent can I say there will be a error. So my confidence is 90% of being correct and 10% of not being correct. So that will be the standard error. Did you all understand what do you mean by standard error? Any doubts until here with sampling, population and standard error? Everybody understood? Now, if you see for standard error, they have given us a formula, that is standard deviation divided by square root of n. So this is the standard error formula. We'll be just applying the formula in the problems. Now let us go to the problem. Now here they have given us the steps to determine the sample size. How do we determine the sample size? Now let's take the same COVID vaccine example. Now in COVID vaccine example, what happens? We will prepare one solution. Okay, we'll prepare one vaccine. Now in that vaccine, can I give this vaccine to all age people? That is a big question, right? So we have somewhere around 131 crore people in India. Now, can I give vaccine to every other age group as the same? It's not possible, because if you see kids, they will not be able to bear how much an adult can bear, right? A person in the within the age of 18 to 30, or let's say 20 to 40 years of age, that person can take more, they have more capacity to tolerate the pain. Okay, people less than that 18 or 20 and more than 50, their tolerance to the pain will go down. Okay, the tolerance to the pain will go down. So you can see small kids, when they fall, they'll start crying. Immediately they'll start crying, especially before 10 to 12 years of age, they immediately react. And old age people, they usually have body pain or joint pain, some of the other thing will be there for them. So I cannot have the vaccine dosage same for everybody. Okay, that is one point. I cannot have same dosage. One, no same dosage. Second point is, this is one scenario. If at all I want to give same dosage for everybody, then what should be there in the medicine, right? So if I have to give same dosage, let's say I am giving 1 unit of medicine to everybody, from baby nursery, playgroups, children, first standard children, second standard, 10th standard, PUC, degree, masters, people at home, old age, everybody I am giving the same 1 unit of medicine. How should I prepare the medicine in such time? That is also a big question. It's a very challenging task. And when I see the sample, when I see the trial of the sample of medicine, I will have to check it on every other age group, and only then we will be able to know, or we'll be able to understand the reaction of the medicine that takes place in the body. Okay, so there is also a way to determine the sample size. Now I determined the sample size saying I will take 2 from first standard, 2 from let's say somewhere about 7th standard, and 2 from PUC, 2 from degree, 2 from masters, and 2 working people. So I am deriving the sample size. I'm saying 2 from here, 2 from here, 2 from here. So I'm deriving the size. And then I should also decide the confidence level. I should say, see, for working people, 99% I am sure that the medicine will work. See, I'm taking medicine as example because you will be able to relate it easily. But the same concept is used in the profit of the firm. Okay. Now, when I'm deciding on the confidence level, I will say, I have 95% confidence that it will work. Another 5% is standard error. Another 5%, anything might happen. But 95% I am okay. I am very confident saying it will work. So this, you will have the method of checking or method of defining the sample size. So understood this? Any doubts in this part? Now, moving further, we just have to know the formulas of the sample size. Now, throughout this chapter, you are only asked to solve the or find out the sample size. Now, I already told you previously they were giving us the sample, they were giving us the data of 10 people, 5 people, 6 people, 8 people, and they asked us to find out the mean, variance, standard deviation, correlation, regression. And we already solved in the previous semester also mean, median, mode. We have solved all that, right? But here they are giving us all this extra data, that is mean, median, mode, standard deviation, all this they will give us, and we have to find out the sample size, that is that x and y data, whatever we were given, that we will have to find out. Okay, so there is a formula, that is the formula for sample size when standard deviation is given is n is equal to z into standard deviation by E. E is the standard error, that is how much error am I accepting. So if I am 95% confident, 5% is the error. If I am 90% confident, 10% is the error. If I am 99% confident, 1% is the error. So that will be in the form of E. So Z into standard deviation divided by E whole square. So this formula when standard deviation is given. And the other formula is when population proportion is given. This we will see directly in the problem for you to understand. Now the first problem here, a sample of 200 chocolates had a sample standard deviation of 0.4 grams. Now there is a sample of 200 chocolates. Yes, this is a good example for you to understand. See, they prepare different types of chocolates. Now you can see from Amul or Dairy Milk, you have Dairy Milk Silk, you have Dairy Milk Red Velvet, then there is some new edition which comes only during Valentine's Day, right? And only during Thanksgiving Day only. And there is one new flavor which is there, I'm not very sure. And there are old flavors like roast almond, fruit and nut, raisins. Then if you talk about dark chocolates, you have varieties. Now how do they come up with those different taste, all that? They will have some sample. First they will do some experiment, they will do a sample. Even better example, let's say you people watched, or you people like following some food videos. Now everybody has become chef, no, in the lockdown. So now we are watching YouTube for cooking. So you will watch the video. Will you directly do it for 10 kgs, 50 kgs and all? No. You will first make very less quantity. Okay, because you're doing it for first time, you'll make very less quantity. You'll see a sample. You'll see, okay, what has to be added next time. How can I improvise, right? So that small quantity what you do is a sample. Now in this problem, 200 chocolates are sample. They will be manufacturing some lakhs and crores of chocolates. Okay, out of so many chocolates, 200 chocolates are sample. And this 200 chocolates has a sample standard deviation, which is sample standard deviation is 0.4 grams. Chocolates are usually in grams, they are not in kg. Okay, they're usually in grams. So sample standard deviation is 0.4 grams. Now, how many chocolates must be included? Listen carefully. How many chocolates must be included in the sample? They're asking how many chocolates we have to include. If the investigator wants to be 90% confident, so they're asking how many chocolates should I make it as a sample. Now, out of lakhs of chocolates, 200 chocolates I've taken as sample. Okay. Now, out of 200, I am drawing another sample. This is something like this. That ball had 500 balls. Sorry, that bag had 500 balls. Now, out of that, first time we picked 5 balls, right? This is something like that. We are deriving this 5 now. We know there are 200 chocolates here. Out of that, how much should I pick so that I am 90% sure, I am 90% very, very sure that the mean, the X bar value of this 5 chocolates, let's say for example, this chocolate is 0.1 grams. Okay. So if the investigator wants to be 90% confident that sample mean is within 1 grams, 0.1 grams of the population mean. Did you all understand the question? See, understanding question is important before solving it. After that, solving is very easy. Just put the numbers and into the formula. Did you all understand the concept? Or you want me to repeat it once again? Okay, so we are finding out this 5, this sample size we will find out. Now let us do that. So first, and in the examination also, they will give you this Z value. In the next class, I will teach you how to find out these values and all that. We will see that later. So Z value is 1.64. Standard deviation is 0.4 grams. And standard error. How standard error is 0.1? I am 90% confident. So I am 10%, I am not confident. So this will be error. So 10% means 10 by 100, which is 0.1. Now put that into the formula. Now here standard deviation is given.